We have our order service created with the base skeleton code ready, and also we have configured a RabbitMQ, and then we have already verified how to send a message and then receive a message. So we are ready to implement our next API endpoint, like create order API. In this video, we are going to implement that create order API, and also as part of this, we are going to explore how to use records as JPA Embeddables, and then we are going to cover how to unit test controllers using Spring slice test annotations like at WebMVC test. And we are going to write our unit integration test using Testcontainers, and also we are going to take a look at how we can use a library called Instancio for generating the test data. So usually while writing test, we need to populate some beans and then use it. So there are many such libraries, but I personally like this library, so I'm going to demonstrate how we can use this library to generate the test data. So let's get started. Let's take a look at what we are going to do as part of implementing this create order API. In the earlier videos, we have already created flyway migrations for creating orders and order items tables. So in this video, we are going to start with creating order entities, order and order item entities, and then we start building our API endpoint, post API/orders. And as we discussed earlier, currently we have not yet implemented any security, OAuth-based security, but every order will be placed by some logged in user only. So in this video, we are going to create a dummy security service which simply returns one static username, pretending that that is the order placed by user. And we are going to write unit and integration test for this API endpoint. So here you can see what is the request payload would look like. So we are going to capture some customer details, and then to which address the order should be delivered, and one or more items. So here as part of the items, we are also going to take the product code, what is the name of the product, and price and quantity. And if everything is successful, we are going to return 201 created with the order number. But there could be scenarios where you receive an order where product code is invalid, which does not exist, or if the price is incorrect than what it is there in the current catalog service. So we are going to check that and then throw the error. But in this first video, we are not going to compare that by calling the catalog service. That there is another card for that. So in this video, we are going to just take this payload and then store it in the database, and we are going to write test for that kind of scenario. Implementing create order API involves writing a lot of code. So instead of me keep typing while you are watching this video, I thought it would be better to create the code ahead of time and then walk you through each code snippet so that you will be able to understand what we are doing here. So here, first let us take a look at our existing flyway migration script, which contains the database table descriptions. So we have our first table, orders, which is having a primary key auto-generated from the sequence, and then we have a order number that we are going to generate dynamically, and username represents the user or customer who placed the order. And then we have customer details like name, email, and phone, and we have delivery address to where this product is supposed to be delivered, and order status and things like that. Similarly, one order can have multiple items, so we are capturing those details here. So first thing is we need to create JPA entities for representing these orders and order items. So let us start with that. So under domain package, we have order entity, which is a JPA entity. And you know, this is same thing that we did in the previous catalog service. We defined a primary key and then used sequence generator. And then these are common properties, order number, username. So, and we have a set of order item entities. So this is all we know about these things. And here we have one-to-many association from order to order entities, and in reverse we will have many-to-one from order entity to order. The next important thing here is if you take a look at our customer details here, we have three properties: customer name and customer email and phone. While we could have created separate properties like this, simple properties like this, there is a better alternative where we can use a customer record or even class, but record is simpler and better. So here I have created a record called customer, and then I have properties name, email and phone, and I have already added this Java bean validation annotations to validate the name should not be empty and email should not be empty, phone should not be empty, and email should be of email regex pattern matching. So once we have this record, we can use that, and then we can use that as an embeddable, and here we can provide this attribute overrides saying that how we want to map this customer property names to column names. So that way we are specifying store the name property value into the column customer underscore name, store the email property value to customer underscore email, and phone values to customer underscore phone. So here right now we have this mapping, and when we store our object using JPA, it is going to store all these values into these respective columns. So easy, we don't have to separately manage all these properties. And even better, in the next scenario, let's say we have our delivery address. Here if you take a look at it, there are 5 or 6 properties that belongs to the delivery address, and instead of writing each of them as a separate properties, we are simply using this address and then using that as embedded object, and we are mapping with this attribute overrides how each property is supposed to be mapped to a different column. So the benefit with this one is, right now we are just storing the delivery address. Maybe in the real applications there will be other billing address also. So in that case you can simply replicate this, and then you can specify instead of delivery address you will have a billing address also, so that you don't have to create a different classes, or you don't have to write all these 10-20 properties separately. You can reuse the same object and still be able to map to different columns. So that is the advantage of this one. And one thing to remember, right now we don't even have this at embeddable annotation. Earlier you are supposed to have this class and with at embeddable annotation, but in the recent versions like Hibernate 6.2, we don't even need this annotation. We can directly use it like this. And also these records, we can use records instead of classes also. So next we have order status enum, again with the different statuses. It can be one of any of these states. So we are mapping that using enumerated using string, not as a ordinal number. And order can be cancelled. So when it is cancelled, we need to store what is the reason or any other comments regarding this particular order. And we have created it and updated it. And when we create an object, we are automatically taking the current date time here. And also usually when we create an any JPA entity, we want to store the created at once and never update it. So we usually don't want to update the created time. So we can set this updatable to false, so that this property won't be updated, this column won't be updated, even though when you are changing the status and then storing it into database. And we have this updated it. So now let us take a look at our order item entity. Again, these are straightforward properties, and we have a mapping back to many-to-one association. And we are saying optional is false, because obviously without associated order there shouldn't be order items. So we are specifying that here, and that's the entities. And again, if you remember, these are package protected, so this doesn't expose to outside of the package. So there is no public for this class. For order entity or order item entity, these are not public classes. So now that we have our entities created, we have order repository, which is extending from JPA repository, and this is the entity type, and this is the primary key. So while using spring-data-jpa, one thing to keep in mind is we usually create repositories for aggregate roots. So aggregate root in the sense, usually when you are talking about orders, first you create an order and order items be part of that order. Without order, there is no order items. So whenever you want to make any change or even create orders or add items or remove items, so if you want to make any changes to an order, you are supposed to do through order entity, not directly doing any changes directly on order item entity. So in that case, we consider order as the aggregate root. So we usually create repositories for order aggregates, JPA aggregates, and do any required operations through order only. Okay, so that's why we don't have order item repository. So we do any operation related to orders through order repository. So we have all this in place, and the next one to take a look at is a security service. As I mentioned, right now we don't have OAuth security implemented, and that is the reason right now I am having a simple method here, get login username, and I am returning a static string here. So there is no logic here. And once we implemented our security, we can determine who is the current logged in user, and then we are going to return that particular username here. Okay, so with all of these covered, let us now start with our API endpoint. So here we have our order controller and mapping the common path /API/orders at the class level. And we have injected order service and security service. We have looked at security service already. We are going to take a look at order service, which contains the most of the logic. So we have one API handler method for create order, which is taking create order request, and then we are looking up who is the current logged in user and taking the username, and then we are calling create order method on the user order service by passing the username and then request. So one thing to remember here, so usually it may be tempting to use, okay, we have order entity or even order DTO. Maybe if you have order DTO also, it is kind of a tempting to use those instead of creating another object. But usually while creating an order, or usually any API endpoints, when they take certain payload, it is recommended to create a specific object representing that payload structure instead of simply reusing for other DTOs or other entities. The reason being, if you directly use order entity as the payload, so here when somebody looked at the Swagger documentation, they see ID property, they see order number, they see username, but these are not the values that we are expecting from the payload. Order ID is going to be generated and order number is also going to be generated within our application, not expecting from the client, and username we are going to take it from our current logged in user context. So these are all not being expected as part of the payload. But if you use this order entity or even order DTO here, the Swagger documentation looks like we are expecting from the people who are calling our API. So it kind of misdirects what we are expecting as part of the payload. So always it is better to create a custom DTO or record, whatever you prefer, that represents clearly what is the expected payload. Okay. So here we have this create order request, which is taking a set of order items and customer and address, delivery address. Again here, this order item is a record. So in the models package, we have address. We have already saw this, and then there is customer, and now we are seeing order item, which again takes code, name, and price, quantity. So we have used Java Bean validation annotations to verify the integrity of this data, incoming data. So now let us go back to create order request, and we also specify not empty. So this set should not be empty. It should contain at least minimum one element in it. And also, because we want to validate this payload according to the Java Bean validation API annotations, here we need to add this @valid, which is going to trigger the validation within the nested object itself. Okay, so this is our payload, and then we have our response. It is simply returning order number, nothing else. So with that said, that is all we have in our controller layer. So basically, controllers should be thin, where you just extract the data from the incoming request and delegate the actual logic to service, and then you return the response. So that's why that is a better way to organize your decoupling from the web layer logic. So it can be called from a web API endpoint. This logic, actual creation of order, can be called from a web layer, or it can be called from a job or scheduled jobs. So your service layer should be completely independent of any web related things. Okay. Now finally, let us go to our order service. So here in order service, again we marked it as a Spring Bean Spring service here, and usually the service layer is transactional. That means anything that happens here is going to be performed in a transactional context. It starts a new transaction here and execute everything in this method in a transaction, and if everything goes fine, it is going to commit the transaction. So here we injected order repository, and here within this method, first what we are doing, we got this create order request, and then first thing we are doing is we are using order mapper and convert the request to entity. So here it's a static method because we don't need any other dependency. So that's why it is not even made Spring Bean. It's a simple copying the properties from request to order entity. So here I am manually doing this, but there are libraries like mapstruct where you can configure it to automatically populate the data from request into entity. If you prefer to use that, go for it. And here what I am doing, I am creating a new order entity, and then I am setting this order number to a new UUID number, random number, and then I am setting the order status to new, and I'm populating the customer taking from request to new order delivery address, but mapping order item entity from the request here. So populating all of them and setting it. So just extracting the data from this request and creating the order entity. Simple. So once we have this, we are setting this username into this new order, and then finally we are simply calling order repository.save. This is going to save the order, and we are simply returning create order response with the created order number. Okay, so it is straightforward. We are just taking the payload and then validating it and then storing it into our database. What happens if we are passing invalid payload? What does that mean? So in our create order request, what happens if we are not sending name or email or phone number, right? It is going to throw exception because the payload is invalid. So what kind of exception does it throw? So it is going to throw method argument not valid exception. But currently how it is going to be handled? If you remember, we have our global exception handler, and by default we are extending this from response entity exception handler. So here if you search method argument not valid exception, so this is the exception it is going to throw when we pass invalid payload, means missing any required fields or passing some invalid data. So in that case it is going to throw this exception handler, but this exception handler will be handled automatically in a default mechanism, and it is not it may not be the format that you are willing to return. The error response may not be the format you want to return. So that is why we are overriding that in our global exception handler. We are overriding this method. So here we have this method which is handling that exception. So we are overriding this method in our global exception handler. So what we are doing here, because it is a method argument not valid exception, we can get all the errors that happens in the binding and then iterate through all of them and then fetch all the error messages and make it as a list of errors. And then we are as usually creating the problem details instance. And in addition to other details, I mean here in this case it is a bad request. So we are going to use the status HTTP status bad request. And also in addition to that, the custom property we are setting errors is errors. So this is one way of handling how to handle some of the framework level exceptions. Like here method arguments is not valid, so we are handling it in a customized manner. First let us validate this implementation through Postman. So currently we have our infra components running, database, RabbitMQ, everything is running, and right now let me test with the Postman. So here let me first start the application. So the application is started. Now let us go to Postman. Here I am passing the payload here with all the fields, and then let me submit it. So everything is fine and we are getting the order number. This is a generated UUID which is the order number. So our implementation is working fine. We got the status code 201. So everything is fine. Let us say we have country is mandatory, right? So what if I pass empty value for that? So we are getting the error response, and here you can see under errors country is required. If there is more than one error, it is going to return all of them. So like that you can return multiple errors. So the API implementation is working now, and we are able to test it manually using Postman, but writing automated tests is the better approach, right? So that is what we are going to do next. So here is our order controller, and basically you can write integration tests which loads the entire application, and then you can issue a request, HTTP request, which goes through all the controller, service and repository and perform everything talking to the real services, and then you can verify the behavior. That is usually integration test. But also you may want to unit test so that you want to test only the web layer. For example, here you want to test only the web layer for different failure scenarios. For example, in this case, what are the situations we can test this API endpoint? So here we are saying this is the payload, and we have various scenarios here. If you pass a set of items, that is valid, but if you don't pass any items as part of this request, that is one error condition. Similarly, there are many mandatory fields. What happens if you don't pass one of the field? It can be name, it can be email, it can be phone. So any of the fields missing from customer is a error condition. Similarly for address also. So except address line 2, all other fields are mandatory. So there are many failure scenarios that you can test, but here these are all failure scenarios that are going to fail at this binding level only. It has nothing to do with rest of the implementation. So in this case, instead of using a integration test, I prefer to use a slice test which tests only this controller level, so that I can pass different invalid payloads and then simply verify it is going to return bad request or not. I don't have to write an integration test which goes through all of this. Okay, so that's what we are going to do next. So under src test Java, web, we have order controller test, which is a integration test. So again, you should be familiar with from the previous videos. We have created abstract integration test base class, which has @springboot test. @springboot test is for integration test. This loads all the components in your application. So you need to mindful of that, because if your intention is to write only web layer component, you should be using slice test annotation like @webMVC test. If you are writing only repository test, you should be using @data-jpa test or JDBC test, whatever the technology that you are using. If your intention is to write integration test, then only use this. Otherwise, you are going to load the entire application context only to test one component of it, which is waste of time. And then we are importing this containers configuration, so that when we run that integration test, it is going to run both Postgres and RabbitMQ, and our application is fully ready to serve. So here again we are capturing the dynamic port that our application is going to start. Usually it is a random port, so we are binding it to here, and in the setup method we are setting the RestAssured port to that random number here. Okay, so this is the base setup for every integration test we have. So now one JUnit 5 feature is you can write tests in a nested class. So why should we write tests in a nested class? So right now in our order controller we have only one API endpoint, that is to create order. So going forward, more endpoints will come, like we want to fetch an order for the given order number, or we want to fetch all the orders for a given username. So more endpoints will be coming up. So here, instead of putting all of them at the high level, we can organize them in a nested class, so that all the create order related API endpoint tests should be in this class. So it's not mandatory, but it's a good practice. And then next we have first use case where we are checking, given a valid payload, it should create an order successfully. And for that we are creating a payload using multi-line string templates here. So multi-line string support, so you don't have to concatenate all these strings with escaping the double quotes and all that. We can leverage this multi-line string support. So here we have valid payload. We have all the customers information, all the delivery address details, and we have one item also. So the payload is valid. So given that we are passing the payload, so here RestAssured can take entire string payload, or you can even pass a Java bean, which is automatically behind the scenes is going to convert into JSON also. So here we are directly giving a string JSON payload, and then we are posting it to /API/orders API endpoint, and then status code we are asserting that it should be 201 created. And within the body we are checking in the response, we should get a JSON response which contains order number to some value, not null value. It should be a valid some number. So this is our first test. And the second test should return bad request when mandatory data is missing. So here we are calling a utility method testDataFactory.create order request with invalid customer. So just for now, assume that we have a method which creates create order request with invalid data, and we are directly passing that object into payload instead of string JSON payload. And then again we are passing that and then asserting we should be getting bad request. Maybe we can add more assertions, like it should contain, let's say this is the error, right? So we can write another assertion here, just like the way here we can say country is required, or whatever the field we are not passing, we can say verify this is required. Okay, so let us run this test and see. So now it is going to start both Postgres container and RabbitMQ container and automatically configure our application to talk to those containers and execute our tests. So here both of our tests are passed. So that is cool. So next let us take a look at our unit tests. So I have order controller unit tests. Here, instead of at springboot test, we are using web MVC test, and also specifying this is the controller I am writing test for, so that it doesn't need to load any other classes or any other controllers. We are just writing a test for this controller. And while using this at web MVC test, it is not going to load any other beans except the web layer components, which means here our order controller depends on order service and security service. But while using this at web MVC test, they are not going to be in the application context. So some way we need to provide them to be part of application context. So we are using this mock bean annotation and creating these two order service and security service. So what does this at mock bean annotation do? While creating the Spring application context, by default, while using this web MVC test, it is going to load all the web layer components and a framework level web layer related things. But it does need, our order controller does need an instance of order service and security service. By using this mock bean annotation, it is going to create a mock bean implementation of these two and then make them part of the application context. So they are simply mocks. They don't have any behavior. If you call any methods directly here, it is going to return whatever the default value they are going to return. They are not going to actually call this method. Okay. Now we auto-write the mock MVC, and we are going to use object mapper from Jackson to convert object into JSON format. So we auto-write all of these. So both of these mock MVC and object mapper will be auto-configured while using web MVC test. Okay. Now before each, I'm simply mocking the behavior of security service.get login username, because this is a mock, and when you simply call it, it is going to return null. So we are stubbing this behavior to return some any name. Here I am returning Siva. So now it's a little complex right now, but let us start with simple. So first, when we make an API call, we are going to pass the content, this payload. Let's assume some way we have created an instance of create order request with all the data that we need, and then we are using the object mapper and converting that into a plain string and posting that to API/orders, and we are expecting the status to be bad request. But when we make this call, we also need to specify the behavior of the dependent service. So when we call this, it is going to call order service.create order, right? So we are just mocking that behavior here. So how we are setting up, given order service.create order, and here we are saying if you pass the value Siva for the username and any create order request, it doesn't matter what values does it contain, any value, simply return null, because we don't care what it returns, because it is not even going to that phase also, because we are passing the invalid request payload. It is going to fail anyway at the binding time only. And I believe we don't even need to mock this, because our logic is not going to reach to this point. But I'm just explaining, if you are writing another test where you are passing some data and it is going to fail based on the various condition, based on the what it is going to return. So this is how you can stub. Okay, this is how you can mock the behavior of method. Okay, in this case we are going to pass invalid data. I don't think we even need this one. Okay, so basically we are constructing the payload and then posting it and then asserting the status, HTTP status code is bad request. That is a simple process. Maybe you have done this many times also in the past. But one of the best practices to create the test data in a meaningful way. Meaningful way in the sense, we have test data factory class, and we have various methods like create valid order request. So without going into the implementation detail, just looking at this method name, we can say this is a method that constructs a valid order request. And here create order request with invalid customer. So it conveys a meaning that it is going to create an instance of create order request, but the customer data is somewhere invalid. Create order request with invalid delivery address. Again, it conveys that we have a create order request that contains some invalid delivery address. Okay, so this is very important, where it is going to be really helpful. Suppose if some new person joins and they want to construct a new object with some use case. So these methods convey really what exactly this logic is doing without even going into the implementation detail. And we can use these methods in various test cases, because it is logically, it reveals the intention of what does this object do, what kind of a data it contains. By calling this method, what kind of object you are going to get and with what kind of a behavior. So from the readability point of view, it is very helpful. You can even without writing all this, you can directly create order request object and then populate data wherever you require. For example, here we need data with some invalid. Right away here we can create that object. But here everywhere in every test, you are going to end up doing the same logic again and again, just with a slight differences. Especially as and when project grows, it becomes a struggle to understand where else we need to change all that logic. Whereas with these helper methods, it is kind of a centralized, where you can change in one place. Let's say we added one more field, you can come to this place and then we can add this here in a centralized and logical manner. So that is what we have. And here I am using parameterized test. So basically in our case, we are trying to test the bad payload scenario, and we have multiple such scenarios. As I mentioned, if there is no order items, that is one case. If the delivery address is invalid, that is another case. If the customer data is missing, that is another case. So in that case, one option is to create a separate test for each of those scenarios, or another option is to use a parameterized test, where you can provide a source for that data. So in this case, we are using method source. That means it is going to automatically call this method, which returns an instance, a different instance of create order request. Here we are passing 3. Okay, so by specifying this method source, it is going to call this, and for every iteration, it is going to use one of the object returned by these values, these method invocations, and each of these methods will be passed as the arguments to this method, and we are executing the test based on the given create order request input. So here multiple things are going on. One is, first we are using parameterized test, and then we are using method source, and again within that we want to give a logical name so that while running the test, in the IDEs we can see what kind of a scenario we are executing. So here the first case is creating an order with invalid customer data. The second one is invalid delivery address. So how we can do that? We are going to use this static imports of arguments and then named. So using named, we can give a logical name to this particular use case and pass the actual request data for this test. So this way we can return a stream of arguments which is going to used by this test for every execution. Okay, now let us run this and see how it displays. So if you take a look at this, it is showing 1 order with invalid customer, 2 order with invalid delivery address, 3 order with no items. So here we have customized this how we want to display the names that shows in this test results pane. So here we are constructing, first we are want to show the index and then the first argument. So the first argument here is this one, the scenario name. Okay, so this is how we can make it more pleasant for developers to show how we can write our test in a more easily understandable manner. So we have seen how to write integration test using REST API and test containers, and we have seen how to write unit test for our controller using slice test annotation. This is called slice test annotation for web layer, and we are loading only controller and marking the dependencies of this controller. Okay, and then we are verifying it. So if you feel this is confusing or anything, maybe take a look at JUnit 5 documentation and read about parameterized test. It is simply to pass multiple values to this test and use that input in our test. And how to pass these different values? There are multiple ways. One is method source, or you can even say CSV source, or even you can provide enum values. So there are different types of mechanisms to provide inputs to the test. Here we are using method source, which means simply it is calling this method, and here we are passing a stream of inputs. And finally, each of these methods are returning create order request, which we are taking it as an input, right? So all these methods are returning create order request. Now coming to how we are preparing this data. This is where I said I am using a data generation library. For test data generation, I am using Instancio. So basically how it works, once we add this library, so here I have added Instancio JUnit dependency here. Once I added that, this is how I can construct. So by default, you can simply say instancio.of whatever the class that you want to create an instance for with some random data. You can and then you can simply call .create. Without any of this, you can simply call instancio.of whatever the class that you want to set the sample data .create. It is going to set the random data. But here we need some kind of some meaningful data for certain fields. For example, for customer email, it should be in a proper email format, like some alphanumeric character and @ symbol and some domain name. So we are customizing how some fields are supposed to be populated. For other fields, it is okay to have any kind of a random type of data. So we are using a different mechanism to set different values. One is generate. So this generate, we are saying for this field, within this create order request, there is a customer within that email. So for that, we are using this generator. So this generator contains several mechanisms, like if we want to generate some kind of a text, okay, otherwise booleans, characters, collections. So there are different ways of generation, and we want to generate using a pattern. So in this pattern, hash A represents any one alphanumeric character. Similarly, if you can use hash C, this is a lowercase character, one character. So here we are saying any 4 or 5 alphanumeric character and then use @mail.com. So we are saying generate a test data for the email field, but in this pattern. Okay. Similarly, for our orders, we want to set some valid product ID values like that. So here we created a static field valid order items, and we constructed some valid data, and here we are directly setting that value for this field, items field. Similarly, for country, delivery address country, we assume we want to use only certain values. So here I have a list of strings and it contains India and Germany. So here we can use this generator where it says one of this list. So whenever an object is created, it will generate country value based on one of these values. Okay. So similarly, here create order request with invalid customer. Again, we are using almost same thing, except that we are saying for customer phone field set empty value, which is invalid. So you can do this for other fields as well, like a phone, if not phone, for email or name, you can. So overall, we are constructing a create order request with phone value as empty, and rest of the fields are same. Similarly, we are following delivery address with invalid delivery address. We are setting the country value to empty. And finally, create order request with no items. So here we are setting create order request with the items as empty set. So this way you don't need to worry about writing all the code for setting all the fields. For example, here it is, though it looks simple, we have a set of order items, and then customer. Within the customer there are multiple fields, within the address there are multiple fields. So it might require a lot of boilerplate coding, whereas with this Instancio, it is simply populating all these fields. So we can see when we are running this. Let us just print the request object. So I'm just printing the request so that we can see what kind of a data it is generated. So here for the first scenario, we can see it generated with order items, and then for customer it generated a random name and random email, and phone is empty, and delivery address with random values. Okay, for invalid delivery address, again it populated valid items, but customer is valid, delivery address, country is empty, and for all others you can see it is all some random data. So for last, items is empty, others are valid data. So like that you can use this library to set up your test data in a meaningful way. We have implemented the create order API in its bare minimum format, like we are just taking the payload and doing some basic validations and then storing it. But there is a little bit more to this API endpoint. So once we receive the payload, we need to call catalog service and then verify whether there is an actual product with this code, and is the current price is matching with what we received as part of this request. So if either product is not there, or if the price is not matching with what catalog service is having, it is an invalid request. We should respond with a bad request. So for that, we are going to implement a client for catalog service in our order service, and then we are also going to look at how we can use resilience for J for handling what if the service is down, what if we want to retry. So we are going to use resilience for J and then implement that circuit breaker pattern and retry mechanism, okay, with a fallback. So that's what we are going to do in the next video. I guess we have a basic implementation of creating order API ready. So we are going to tackle the upcoming parts, like once we perform the order validation by talking to the catalog service, we also need to publish a message to the RabbitMQ saying that a new order created event happened. So we are going to tackle that in the upcoming videos. Thank you. Bye bye.